interface is a direct connection between a human and a machine. This could take the form of microchips being implanted within a human brain. It could take the form of some sort of wearable device or something of that nature. And it kind of allows for streamlined communication between the human and the device directly. Now, there's a lot of ethical questions surrounding that, and that's kind of what we're going to talk about today. But first, to kind of explore the technology itself a little bit more. Essentially, how BMI works is that neural signals are produced from the human brain and transmitted by the technology essentially to the human nervous system to elicit a response. As you can see, for example, here, it's kind of showing you a little diagram of human brain waves being read, processed, and then electrical signals being produced, which is, in this case, causing a prosthetic arm to move. As I've said, there's great potential for benefits for this technology in society in the form of allowing, for example, a prosthesis to work, but there's also many ethical questions surrounding it. But to talk about a few types of brain-machine interface technology, electroencephalography is one of the major forms of BMI technology, and it normally takes the form of a wearable device, like some form of headgear, kind of like a cap of sorts, as you can see in this image. And there's electrodes placed at various different points on the skull, and essentially it reads the human brain waves and generates kind of a report, if you will, that a computer can then process and can then generate electrical signals to produce the desired response based on the reading. Magnetoencephalography maps the brain via neural signal tracking. Electrochemical properties generate kind of ion gradients that produce the image of the brain in this case. There's then kind of implants that detect and amplify the magnetic fields, which is the basis of the reading here, and then that signal would then be transferred. And functional MRI technology is kind of a subtype of magnetic resonance imaging, which is something that a lot of you are probably familiar with from just medical technology and MRIs and things like that. What it essentially does is measures the change in blood flow as a result of neuron activity. And when you're kind of being, when an fMRI is being read, the subject is alternating between periods of activity and periods of rest. So maybe you might be on a treadmill or something, running and then resting for a period to develop different maps of the brain. This is probably the most recently developed of the types of BMI technology, but it's definitely gaining a lot of traction. And then electrocorticography technology is surgical implantation. It's, of all the ones we talked about, this is the first invasive form. In this case, the electrodes are actually making direct contact with the brain, and as a result, it produces the highest quality readings and the most effective results. The issue is that it's much more invasive and expensive, and with the dangers of surgery. But now to kind of talk in more practical, real-world sense about some of the current areas of BMI research. Dr. Miguel Nicolelis is a researcher at Duke University. And he's developed in a bodysuit for paraplegics using BMI technology. This was debuted at the FIFA World Cup in 2014 in Brazil. Essentially, you can see an image of it here. It's kind of a large bodysuit with headgear and things like that. The headgear uses EEG technology to kind of read the brain waves and send the correct electrical signal, which allowed a paraplegic wearing this suit to walk and kick a soccer ball at the tournament. He then received electrical feedback sent back up his nervous system, which kind of gave him the sensation of the feeling of kicking the soccer ball itself. Another area of research at Wits University in South Africa is the first direct connection between a human brain and the internet. There's an EEG device that's attached to the human brain from which the signals are directly gathered and then sent to a Raspberry Pi computer. The data is then put on an application programming system and it's live streamed on the internet. At this point, that's kind of just a basic connection to the internet, but it kind of opens up avenues for a lot more advanced stuff that could be done with the internet and the human brain. But now that kind of leaves a lot of questions for where BMI could fit into the future. For example, in education, if students were to be connected to some form of BMI technology in schools, they'd have kind of immediate access to a wealth of information on the internet. That could change the way the entire education system. It could change the way that teachers instruct. based on the fact that kind of all the information would be there. It would just be a matter of translating it into knowledge. The questions could arise of whether or not that would be supplanting or helping teachers, and whether it would be good or bad for the educational system. In law enforcement, BMI technology could be used kind of in interrogation tactics and things like that. It could be attached to a subject to kind of read brain waves as kind of a more sophisticated polygraph, if you will. It could also be used by police officers to kind of increase senses and things like that. But again, technology like that falls in the wrong hands could be used for significantly dangerous purposes. And then just the idea of human enhancement is something that comes up a lot in BMI technology. Essentially, if we think of a form of it today, if you think of like cochlear implants, that's a form of BMI technology in the sense that it's connecting to the brain and enhancing the senses. Microchips could be developed to enhance human sight, hearing, pretty much any sense. And that could create a more effective workforce, that could create a more effective, a stronger, healthier society, but it also raises questions of what kind of dangers could occur if this power is kind of given to everyone. And I know that sounds very science fiction-y, but the technology has the potential to become reality in the future. And so now to kind of delve more into the main focus of the presentation, which are those ethical questions surrounding the technology. We kind of have to ask ourselves questions. Would BMI technology in education benefit students? Would that kind of enhance the efficiency of our education system? Or would it be undermining the very process in which it's built? Would it be helping teachers do their jobs more effectively and efficiently? Or would it be supplanting them? And how would that impact education? In law enforcement, would it create a stronger and more efficient system of justice? Or would it create dangerous scenarios in which power was being abused and innocent people were suffering as a result? We have to ask, kind of in the sense of human enhancement, would it create a stronger society? Would it create a more effective workforce? Or could it lead to a smaller amount of people filling more jobs and kind of changing our job market in a negative way? Or could even it create a scenario where people talk, in the sense of genetically modified organisms, people talk a lot about the idea of like designer babies, of people being able to pick and choose what their kids will, what kind of genetic traits their kids will have. Could BMI technology create a scenario in which people are kind of just picking and choosing who they are and what they're going to be, and how would that affect society from just an ethical perspective? And how would it affect just humans in general as a whole in a society? Would it increase job prospects? Would it hurt them in our economy? And is this technology a natural progression? I believe that sooner or later this technology will develop regardless. Scientific research will progress and people are going to explore this area, and the technology will get to the point where it has the potential to do all these things. Ultimately, as a society, it's up to us what we do with it. I believe this is something that should be explored but does need to be regulated. We have to kind of strike a balance that allows for the development of science and the technology into all of its potential benefits for society without allowing it to become something dangerous or harmful. There must be formal legislation in place to regulate it before it kind of gets out of hand, but at the same time, we can't prevent exploration or research in these areas. These are difficult questions to answer for anybody, and I don't have the answer to everything regarding this technology, but at this point, nobody really does. The one thing I do know is that it will develop, and that this technology is inevitable, and being educated about it is critical to our society being responsible and developing not only in an ethical and moral sense, but in a legal sense, the correct framework for which this technology should develop and interact and be used so that we can maximize its benefits without bringing about any danger or harm or anything of that sort. Thank you.